Hi everyone, welcome back to the workshop, and it's repair time again. And this time I've got another digital oscilloscope. And this one's from Dominic here in the UK, kindly donated to the channel. And what Dominic says about this one is, the display was okay, but showed an error. But then, after he powered it up a little bit later, it popped and there was some smoke coming out of it. So he obviously shut it down. Now it's a Tektronix 2430, which is a digital oscilloscope, and as you can see it's looking a little bit tatty. It looks like it's got some paint or something like that splashes on the actual CRT screen there, and it's a little bit grubby, but I'm sure we can do something about that. But first things first, let's open it up and take a look inside. Right, well, these screws here in the back look a little bit weird. Maybe they're not the right ones, because you've got the screw all right, but you've got a nut wound right up to the end there. That's probably not standard. I wonder if these have been replaced at some point and maybe they're a bit too long. Anyway, I'm sure we can replace them. In actual fact, there's only 3 of them. We're missing one anyway. There we go. Let's pull the back bezel off, and we should be able to pull the case off, I think. Yep. Wow. That looks like something the Borg built. Wow, just ICs galore on the sides, on the top. What about the other side? Well, looks like we've got some HV stuff there. Yep, there, and we've got a big fan. And the underside. Wow! This must have been expensive to design and make. Wow. And wow, something's just fallen out round the back there. I wonder what that is. That is part of a reefer capacitor. And I'm betting that's what went bang and let out the magic smoke. But I don't see any power supply components anywhere soon. It looks like, yes, it looks like, let me zoom in a little bit here. You've got hinges here on this large PCB, so it looks like it'll flip up like that and we'll get into the inside. So I'm going to do that right now. Ah, here we go. I've got another board sandwiched to it on the underside. Wow. But it looks like I'm going to have to disconnect some ribbon cables first. I've got this flat flex here. I'm going to have to be careful with that. I think that just unplugs. And there we are. And that's us on the inside. Well, there we go. We've got a cover here. I think that might let us into the power supply section. Now there is a service manual, but I'm winging it for the time being. So let's take off some of these screws and try and get inside the power supply section. Now the CRT's right here, so I'm going to steer well clear of that. Are we nearly in yet? Yes, I think we're in. Wow. Ho ho ho. Let me reposition the camera. Well, hopefully you can see this. We've got two reefer capacitors just absolutely blowing themselves to bits there. Wow, no wonder this thing was smelling a bit and smoking and popping. We'll have to do something about that. And this is on the low voltage power supply of the unit, so we'll have to take it out. And this is the low voltage power supply here, and it looks like it just comes straight out from this angle. But I'll double check with the service manual, just check what screws we've got to take out, which connectors, etc. before I actually attempt removal. Going according to the service manual, first thing I've got to do is remove some spade terminals here. If I can just pull them out. Wow, that's tight. Might have to use some long nose pliers. Wow, that's tight. I'm actually going to mark them. I've got two of them here that are the same colour, so P70 marked with a 7. There we go. And the next one, P80. There we go. And I'll mark that one with an 8. We've got another one, P60. Someone's been in here before because somebody else's pen marks are on it. There's an L marked on that one. And finally, P30. There we go. Mark that one with a 3. And there's a few latches I've got to turn a quarter of a turn anti-clockwise. Well, they're already anti-clockwise. Someone's been in here before, obviously. Yes, definitely. Another one hidden down here. Yeah, they're already been turned. They haven't actually been locked. And a mounting screw to remove. There we go. And some cables. A large ribbon cable here. There we go. Flip that one up. I've got another one down here. That one will be a bit harder to get to. And I think that's it. So it should just lift out. Trying to lift it off of those latches when they're a little bit battered is not so easy. That's that side. There's another one at the back here. Wow, that's tight. This one at the back here has been a little bit tight. Wow, it's tight. Check and see if it is unlatched. Yes, it is definitely unlatched. It's just not wanting to go down through this hole. Wow, it's tight. Don't think there's any other screws, not according to the service manual. Oh, wait a minute, there is. Yes, I missed one. Did I misread the service manual? Possibly did. I think this one here needs to come out. Let's try that again. That's better. Easy does it. There we go, I'm getting there. Yes. Yes. No problem. Let's take a closer look at those reefers. Yes, they're in there. Wow. And look at this reefer cap here. There's a resistor right next to it and it's got a big crack along it, so that's gone as well. And this reefer over here, well, there's another resistor here. It's not cracked and it's a little sufficiently far away from the reefer. However, it's got a bit of a bend on it for some reason. Don't know if that's just the quality of the manufacturing at the time, but it could have been overheating, so I might just replace that one as well. The rest of the AC side on the power supply, I've got some large electrolytics here. They're not leaking, they look okay, but I will measure them in circuit. Got a bridge rectifier behind it. Down here, looks like a 1 amp job, something like that. It looks okay. And a few other components as well, a thermal switch there. And in and around here, doesn't look to be any problems at all. Apart from maybe this cap here. It's not bulging, but it's a little bit discoloured down the side of it. I'm not sure, but it looks like a Sprague cap, to tell you the truth, although I can't see any name on it at the moment. But it just looks like it's got some moisture or something like that inside it, behind the plastic covering anyway. But the rest of the caps over there, they look okay. I will measure them in circuit just to make sure. And outside the cage here, we've got a number down here as well. They're certainly not bulging or leaking either. And looking at the schematic, there are the two reefer caps there. They're X2 class, meaning they're across the live and neutral, as you can see. And those two resistors are actually series resistors with those capacitors. So I'm right to change out those resistors, because when the capacitors went dead short, you would have got quite a high current through those resistors. So no much wonder that one of them's cracked and the other one looks like it's bulging a little bit. So I'll change out both of them. The other capacitor that looks like it's been getting a little bit damp or maybe hot, maybe, I don't know. That's C244. It's a 180 microfarad capacitor and it's on the control power supply. I think looks like it generates an 11 volt supply. So I'm just going to change that one out as well. And there is those components marked up on my little printout of the component layout there from my own records. You've got R809, 30 ohms, half a watt. We've got one of the X-class capacitors there. We've got the other resistor, 68 ohms, half watt. The other X2 class capacitor there. And that 180 microfarad, 40 volt capacitor there. So I'll go away and change them out now. And not much left of that reefer cap. PME 271M, X2 class, 0.068 microfarad. I should have something that I can put in place. And the other one's not much better. And those resistors just fell apart removing them, so I was definitely right to change out that bulging one. Now I've got a couple of NTCs here. I've checked them out and they're within spec. They are 5 ohm NTCs and they're reading about 5.5, which is about right. So no problem with them at all. Now there is a couple of spark arresters there as well and a couple of coils. They're intact, a little bit blackened in the side. So I'm actually going to go and clean up this PCB. It's a bit dirty where that reefer has just exploded all over the place. Even on the side of the heatsink here, it's just a little bit marked and all the rest of it. So let's get some IPA on there and let's clean up the board, both sides. Right. Turn off the heatsink first, I think. There's plenty of IPA on. Well, it's not perfect, but I think it'll do. Let's dry it off and then I'll fit the new components. Well, I think I'll use these ones. I've already got one out. I'll take a couple of them. Well, I don't have any half watts the right size, but I've got some 1 watts. I've got the 30 ohms, but I don't have the 68 ohms. So 75 ohms I think I'll do the trick. Right, that's those changed out. Now let's go and look at this capacitor in here. The 180 microfarad 40 volt one. That might be a little tougher to find in my stock. Well, not surprising I don't have any 180 microfarad 40 volt. It's not a well-known size these days, I guess. But I do have plenty of 330 microfarad 50 volt caps. And since it's on the unregulated DC part of the circuit on the schematic there, I think we'll get away with 330, no problem at all. So I've got some Nichicon and some cheap brand ones here. I think we'll go for these ones because the packet's already open. Looks like this cover's got to come off first. I think it's just clipped on. Yeah. There we go. And there it is. As you can see, what I noticed earlier just looks like, I don't know if that's been getting hot or leaking slightly. It does seem to be bulging slightly at the bottom, although it is sealed. There's no vent hole in these old capacitors. But let's just stick it on the ESR meter and let's see what we're getting. 180 microfarad. 218 microfarad. Wow, it's over spec. And 0.26 ohms ESR. Well, we're going to change it anyway. Well, I've gone over all the other capacitors and they're all measuring okay in circuit, apart from this two here. So they're reading very, very high. Might be just because they're in circuit. I'm going to remove one of them and see what it measures out of circuit. So this one is over at an angle here. I'm going to remove it and test it. Well, yes, took it out and it measured fine. In fact, just like the other ones, it measured a little bit higher than its spec 250 microfarad supposed to be, and it was just over 300, so yeah, it looks fine. And the ESR was okay as well, so I'm just going to leave them. The only one that was dodgy, I think, was possibly this one. So I think everything else is okay. I had a general look across the power supply, and everything looks okay. No cracked resistors. Nothing looks burnt out or broken or anything like that, and no bad joints that I can see on both sides of the board. So I think with the new X2 class and resistors fitted and that new cap fitted, I think I can fit it back now into the scope and we'll attempt a power up. Now I'm not actually going to change out the line filter. It's not the brand that can blow itself apart. It's a Strag, so it should be okay as far as I'm aware. So I'm just going to leave that in place. Right, now the awkward bit. Try and shoehorn this back in. Right, put some of these headers back in. Apologise, I've got to put my head right over the scope here. There we go, that's that one in. It's looking like it's going down now. Yes, onto the clips. I think we're in. Right, I'll go away and put the screws in here and connect up the main board again with this flat flex here. Then we'll attempt a power up. I'm just about ready for a power up, but the other test that I like to do, just for the safety point of view, is just check the plug. So I'll put power on and just check the earth first of all. Yep, I've got a good earth, and across the live and neutral 137k, anything leaking to earth? Well, 50, 60 meg, that should be alright. Yep, looks good. So let's try a power up. Okay, let's put power on the wall. And let's power it up. And we've got the fan going. Yes! Running a self-test now. Now I do actually have my own Tektronix 2430A, so we can actually do some comparisons if we run into any error codes or anything like that. Not that I'll be swapping boards or anything like that, because of the size of those boards. That would be a fairly big job, I would have thought. But I do know my 2430A takes a while to boot up. It seems to run a self-test for quite a while. As you can see, I got my finger over the power button just in case anything goes wrong. Now Dominic did say prior to the reefers going that it did produce an error. But we'll just have to wait and see. Yep, there we go. Well, so there's the errors, 7,000, 8,000 and 9,000. And if I go down to the sub-menus for the 7,000, oh, you can see we've got a fail on 7,200, and I can drill down a bit deeper there. And you've got a couple of fails there. And if I do the same on 8,000, we've got a number of fails all over the place. I'll not bother drilling down there. And the 9,000, we've got one there, a fail, so let's go down to that one, 9,200. And yes, A and B trig fail. So as you can see, we've got three levels of errors here. 7,000, 8,000 and 9,000 are all failing there. And we've got the uncaled message at the bottom. Now taking a look at the service manual, it mentions failure of diagnostic test numbers 7,000 through 9,300 may indicate that the instrument calibration is invalid at the present temperature. If that condition occurs, the instrument will enter the extended diagnostics mode, which it has, and an uncaled message will then be displayed. Such a non-fatal condition might exist if the last self-cal was done at an operating temperature that is very different than the present temperature of the scope. In this case, the power-on self-diagnostics detect that the stored calibration constants may not permit accurate measurements to be made. Recovery is made by allowing the instrument to warm up, not warmed up message not displayed in the main cal diag menu, and run the self-cal procedure to recalculate the calibration constants. A diagnostic test number of 7,000 to 9,300 that continues to fail diagnostics after self-cal is done indicate that some condition exists that prevents correct operation. Well, we're not that far here yet. So what we want to do is let the unit warm up, and then I'll run a self-cal. Now you will notice I've got some vertical banding on the CRT there. That's actually a waveform. If I come out of diagnostics mode and adjust the time base, those will change and you can actually see a weird waveform on the display. So I'm thinking that's related to the problem that we've got. There we go, I've just come out the diagnostic screen, and now if I adjust it, you get that, which I find pretty weird. Now what I have also done is check the outputs from the low voltage power supply. We've got a number of rails, plus 15, plus 10, plus 8, plus 5, +5, -15, -10, -8.3, -8, -5, and they're all perfectly okay measured on the sideboard of the unit. So I'm confident enough that the low voltage power supply is working okay, given the issues we had with the reefers, etc. On the sideboard there's some nice test points from measuring those supply rails. I should also point out that whilst I'm running these tests with the cover off the scope, these modules underneath here won't get the same airflow as they do when the cover's on. And it's recommended to run some fans from the workbench up to them to keep them cool, so that's what I've been doing. Right, let's check if we're warmed up yet. Yep, the not warmed up message is gone. We've still got an uncal, so according to the procedure I want to run through a self-cal, so I'm going to do that now. And it's running. And it looks like we've still got a fail, and it still says uncal, funnily enough. So I think that'll do for a part 1. I'm not an expert in Tektronix scopes, especially not one I would say as complicated as this one here, so it will take a bit of digging, I think, through the service manual to try and get some sort of clue as to where those errors are coming from. But if you know what the problem might be, or if you can steer me in the right direction, please comment down below or contact me via my website. I'm keen to get this scope back up and running. So thanks for watching, and remember you can always comment down below, and don't forget to like and subscribe. It really does help the channel grow. There's plenty more repair videos on my channel, from the simple to the complex. Check them out, and thanks for watching.